All right, I was in the gym recently and I came across this little J cup that's used to hold the barbell onto the squat rack while you're using it. And it caught my eye because it just seemed like a little interesting assembly of sheet metal parts, fasteners, plastic parts that would be great to run through as a sort of intro to Onshape assembly and part creation and sheet metal parts. I think that designing stuff that you find interesting around you is a great way to, look at these assemblies in real life and sort of think through how you would make those features in Onshape if you were the person that was designing this assembly from scratch. And running through those exercises just ingrains that into your sort of CAD muscle memory, and I think it's a great way to build out those skills. So yeah, we'll just dive right into it, and you can follow along. Cheers.
Okay, so here is the final part studio with all of the parts inside of it. This is what we're going to be making now. So we can start a new part studio. And a lot of the dimensions that I'm going to be using are kind of off the cuff based on some of the standard sizes of these cheaper squat racks, just because I didn't measure anything that was in there in the actual gym. So we'll start out by making the actual upright, which is the steel extrusion. And I'm pretty sure these are cheaper 50 millimeter by 50 millimeter extrusions. They're not the 3-inch by 3-inch or 75 mil by 75 mil. We'll put a radius of 5 on that. Sorry, we'll set these equal to each other by pressing E, and we'll give this a dimension of 50. Now we can highlight everything here, and we can press O to offset. And we can give this a thickness of 3 millimeters, because I think that's a standard sort of 11 gauge around there thickness. We will extrude this, just so we have something to reference. We'll say 400 mil, and we'll extrude it symmetric. Well, that'll do is it'll extrude 200 millimeters up from the top plane and 200 millimeters down from the top plane. Basically, any number that you put there, it'll make it symmetric about the sketch plane that you're generating the extrusion from. Okay, so this is our upright. I'm pretty sure the holes are 5/8 inch, which is about 15 millimeters. So we will extrude that sketch through. We'll say through all. And then what we'll do is we'll linear pattern these, and I'm pretty sure the standard is 50 mil by 50 mil, 50 mil spacing for the holes. So we'll say we want to direction, we'll put that up. We'll say 4 up, and then we'll add a second direction, same thing there, 50, 4, and we'll reverse the direction and hit reapply features here. Okay, so we have our upright, and now what we want to do is we want to build out the actual sheet metal, sort of like the main component of the sheet metal part that wraps around the upright. And so we'll do that now. So if we take a look at this part, it's actually made up of a bunch of parts. It's an assembly in and of itself. So right here there is this pin that fits through the slots in the uprights, or it fits through the holes in the uprights. There is this sort of main sheet metal body that has these wraparound bend features on it. There's also these 2 J plates that act as the main hold for the barbell. And then there's a bunch of these insert pieces that are made of ultra high molecular weight polyethylene, or HDPE. So ultra high molecular weight polyethylene is UHMW, and then there's also just high density polyethylene, which is HDPE. And I think depending on the quality of the one that you're getting, it could be either one of those. I'm just going to assume it's ultra high molecular weight polyethylene for now. And so that is this part here in the center, and any part that is touching the upright on the front and back face. So there's actually one on the inside face here that's a longer piece, and then there's these 2 little mini pads. So we need to account for these in our spacing when we're laying out the main sheet metal body. And so we can do that by, we'll come over here and we will make our main sheet metal body sketch. We'll make it about the center. And it's just on those front and back faces that are contacting the upright where we have that ultra-high-molecular polyethylene sheet. And we'll make sure that it's contacting the side here. Actually, we'll give it a little bit of a tolerance here. We'll say 0.5 millimeters between that face, 5 millimeters between the front and back face. What we'll do now is we will extrude that sketch into a surface, not a solid. So we will select these edges. We'll make it symmetric. We'll say it's 150 millimeters long. Okay, so this surface that we're making, and we're going to try and make it all at once, will let us then create our sheet metal body out of one surface. So we'll use the convert sheet metal option. When we're creating a sheet metal model, we'll just convert this surface all in one go. But we need to edit this surface now to create those cutouts. So on this side, we'll say we have that shape. We'll say it's 50 millimeters down. And then on this side, we'll do something similar. We'll say 50 millimeters on the bottom. And then on the back face, we're getting rid of both in the center. What I'm doing there is I'm referencing these edges of the sketches that we just created. So if we move these sketches, these two edges will move as well. Okay. And so now what we're going to do is, and there's a bunch of different ways that we can do this, but I'm going to do it this way just to show you some different ways of thinking about these surfaces. We're going to take this face and we're going to split it with that sketch entity. And we'll do that for all three of these faces. We'll split it with those two. And then this one, we're going to split with that line. And now we will use the delete face command, and we'll just delete all those faces. So those faces are now deleted, and we've kind of got our main shape here starting to form. But there's also those cutouts along the top edge. So if you look here, it's not actually a straight edge. It's kind of like this step down on each surface on the top and bottom face that we need to account for. So what we'll do there is we'll go to our side view. We'll select that sketch plane, and we will add in this sort of surface here. We want these 2 points to be vertical with one another. We want these points, these 3 lines. So this is a line horizontal to the origin, which is at which everything is centered on. We'll select those 3 lines and we'll say we want them to be symmetric about each other. So if we move this line, the bottom one's going to move by the same amount. And similar, if we dimension this line, the bottom one will be dimensioned by the same amount in distance. We'll say that that's 25. I'm not sure what's going on with this graphical area here. I'm not sure if you can see that. We'll say that this is this face is 40. We want L. We want that to be vertical, and we want these to be equal with one another. We'll give this a dimension of 40. Okay, and now what we'll do is we will extrude this as one surface all the way through. So it's cutting it through the entire surface. You could say that through all. And now what we'll do is we will split this surface using this surface, and we won't keep both sides. We just want to keep our main body side like that. So I'm going to hide the upright now because we don't really need it. So there's our main surface that we're going to use to generate the sheet metal model of the main body. So to do that, what we'll do up here is click sheet metal model, and we will select this surface to convert. And that's going to give us a rough idea of the sheet metal on each face. We want to make sure that this thickness is going in the right direction. So we want it to face outwards from our surface there, not inwards. If we're facing it inwards, then it's going to overlap with, I'll show you here, it's going to overlap with the upright that we had selected. There. So we want to make sure that it's facing outwards. I'll hide the upright again. And now what it's going to do is it's going to ask us to select edges that we want to bend. So we want to bend this edge, we want to bend that edge, we want to bend this edge, and we want to bend this edge. It's going to automatically create these reliefs in the sheet metal, and those are required when manufacturing these sheet metal components. If you don't have these bend reliefs, what happens is you can imagine if this edge is just right connected to that edge and we're doing a massive bend on the sheet metal there, the amount of stress that is concentrated in that tiny little area just causes the metal to fail and crack. And so these bend reliefs act as, stress relief, and they also act as sort of tool clearance to allow the sheet metal press to get in there. I'm going to adjust the appearance of this to make it match the part that we have. And there we go. Okay, what we'll add in now is our peg. So in the same part studio, we can add another part, and we will make that 15 millimeters, and we will extrude this up to this face on the back side of our sheet metal part. And this is going to be a new part because it's not part of this sheet metal part. I think it's just a steel pin that's either getting screwed in or it's getting welded on to this sheet metal part. Probably welded on. So that's the steel pin, and then there's a little chamfer on the back face here. We'll give it a 2 millimeter chamfer. We'll name these now. It's good to keep those named. We'll name that a 50 millimeter upright. We'll name this our J-cup main body. And we'll name this J-cup pin. There we go. Now let's add the ultra-high molecular weight polyethylene sheets and inserts that are going to be on these interfaces. And what we can do by that is we can extrude this face. So we say we want this entire shape here to be 5 millimeters thick. We want it to be a new part. There we go. We'll rename that J-cup ultra high molecular weight polyethylene back insert, I guess. We want to do the same on this front side. We'll go from the center here up to the corner. And we want to disable imprinting here. And what that's going to do is, I'll show you if we don't disable it, it's going to bring in all of these other features into our sketch. So if I just extrude this, it's going to bring in those bend reliefs, but we don't actually want that included in our extrusion. So we can disable the imprinting, and we could go through and select all those if we didn't disable imprinting, but it's just easier to not have to do that. C for circle here, and we'll give it a little bit of a clearance around our pin. And I'll give that 3 millimeter clearance. Okay, so now you can see if I extrude this 5 millimeters, it's not going to pull in those bend relief features. And we want it to be a new part. And again, we'll name that J-cup ultra high molecular weight polyethylene front insert. Okay, and if we look at the pictures here, these inserts are actually screwed on. So there's threads in the sheet metal part that are, the sheet metal part is tapped, and then these inserts are just screwed on with normal countersink screws. So we can add those as well now. This, we'll find the midpoint here, midpoint here, and we'll create a rectangle centered about that midpoint. 25 millimeter by 25 millimeter. Actually, let's give this, oh, you know what? If we look here, we look at our reference images, when it's on the pole, it doesn't actually come flush to this face. It stops at the radius. So let's go back and edit that sheet metal after we create it with the move face command. We can move that back 5 millimeters by the radius here. So now you can see it's not protruding past that fillet edge, it's stopping right at that line. And we can roll back and everything should update. So now our inserts are also updated based on the adjustments that we just made. Because we're just referencing that face when we extrude this. Okay, now if we go back in here, sketch, we can pull in this center line and this center point, and we'll say 25 by 25. We'll create a hole, and just by eye here, I'm pretty sure these are countersunk M5 clearance holes on this part. We want it to only affect this, because we're going to now go in and add Shift P to hide all those construction planes. On the face of our actual sheet metal, we're going to add those tapped holes. So we'll add the hole back, simple, tapped M5. And since this is steel that we're going to be tapping into, we want the percent of thread engagement to be 50%, not 75. And that's just a standard. It's easier to give the threads a little bit more clearance on harder material like steel to prevent stripping and weird assembly issues. So there we have our tapped holes, and the merge scope is just in our main body. What we'll do now is we will mirror those tapped holes, feature mirror, we'll mirror those holes about our top plane. So now that we've got the other tapped holes on the other side, we don't need to create another one of these parts in this part studio because it's the same exact part on top and bottom. So we'll just use this same part when we build out the assembly. And if we go now to this side, we'll just do the exact same thing. And we can reuse these hole features rather than making new ones. So we'll roll back to just before that hole feature. L for a line, we'll make it a construction line, and we'll add it there. And we will mirror this about that line. So now we've got 2 equal points here, 2 equal lines. And we'll say that that's 15 millimeters down. Again, a lot of these dimensions I'm just guessing based on eyesight and intuition. Again, we don't want it to include the main body. We only want it to include that part and that part. And Onshape, if you bring in a new part, it's going to try and cut through the whole feature. Okay, so we've added that. That's our tapped hole sketch. Now we need one on this face as well. And what I'm using U here to bring in those entities that are the edges of the countersunk holes. So now you can select these edges as well. And when this gets mirrored, because the sketch is mirrored, it's not going to create another set of holes in that mirror. If these were offset and not mirrored about that center axis, and then we mirrored the hole pattern, then these would overlap with themselves, or this hole would get mirrored up here, and this hole would get mirrored down there. Okay, so we've got most of the main body parts here, but now we need to create the front part, this sort of J feature that holds the actual barbell. And again, it is just two pieces of sheet metal that are welded to this main body with some fillet welds there, and then there's another big chunk of ultra high molecular weight polyethylene in the middle. So that center J piece, my guess is that plastic part in the middle is 25 millimeters. So we'll draw our plate, and it's the same part, it just gets assembled onto the other side and welded. We'll draw our plate on a plane that is 25 millimeters divided by 2 away from the center plane. Just half the width of whatever that plastic piece ends up being. So we'll add a plane, we'll offset it 25 millimeters divided by 2 from the right plane, not from that, from the right plane, and then we'll get drawing. So we'll draw a sketch on our right plane. We'll bring in these 2 points just to reference the front edge of our main body. And I'm just going to have a go here at very roughly drawing out that shape. Barbells are usually 1 inch thick, so we'll say that this is 30 mil just so it has a little bit of tolerance there on capturing the barbell. Bring that up to there. Again, we'll say that that is about 15 millimeters, it looks like, from the actual physical model. My guess is that this angle is 45, and that this comes out about 50 millimeters, maybe more, 60. This distance here is probably around 20. That makes, no, maybe it's about 25. And then we've got something like that where it just comes down tangent, so that when you re-rack your dumbbell, it rolls into the sort of cut position. I'm going to guess that this is about 80 millimeters. We'll say that's 5. We'll say that that is 2. And we'll say that this distance from top to bottom is, 50. Why not? This looks like it might need to be more, actually, 20, 25. Yeah, that's looking more like the actual model. Okay, and so now we'll extrude that. You know what, we'll turn it into a sheet metal model just so we're making sure that we're using the proper features here. And again, we'll give that 4 millimeters. Oh, one thing to note on this sheet metal model is usually you want your bend radius to be at least the thickness of the sheet metal or larger. If you can make it smaller on some softer metals, but usually if it's too small, you can end up getting surface cracks on either the inner surface or the outer surface. So this just makes sure that you have enough material while it's bending to flow nicely through the bend. I just noticed that while I was making here that I didn't mention the bend radius thing earlier. Okay, so now we've got our main J support here on the front. This is the piece that's going to get welded on. along with another piece that's exactly the same on the other side. So now we've got to create our plastic insert in the middle. And we can do this by coming around to the back face, and we'll offset, so O, we'll offset these surfaces, these edges by 2 millimeters. And the reason I'm offsetting it is because in the actual physical assembly, it's offset slightly just to make sure that you're not, when you're re-racking, you're always touching the plastic with the bar, not the actual metal itself, just so you don't get that weird metal on metal action. Okay. And again, we want to make sure that we have a closed loop here. Yeah, so we can extrude that by 25 millimeters. Okay, now if we look at our pictures again, there are these bolts that get bolted through, 1, 2, 3, and that's what's kind of holding this plastic in there after these two pieces are welded on. So we'll just add those again by eye for now. It doesn't really matter, it's more about practicing generating all these features. And I think it's something like that. This one is vertical to the midpoint there. We'll give it a distance of 15 millimeters down. This we'll say is 15 millimeters from the bottom and 25 millimeters from the side. This one we'll say is 7 and 50. Okay, and those look again like M5, so we will add our holes. M5, we don't want them to be tapped, we want them to be clearance because we can see from the assembly that it's a bolt going through with a nut on the other side. And there we go. There's our parts. And these are all the parts that we need for our assembly. What we'll do now is we'll go in and add all of the fillet features to just clean up the look of these parts. This main body here has some pretty large fillets on it. I think 5 millimeters is probably right. When I'm applying fillets and chamfers and sort of finishing touches, I always like to do it at the end of the feature tree, just because if you start doing it early on or while you're making the parts, then you can oftentimes reference edges that are created by the fillets. And then if you go back and remove the fillet or change it later on, then sometimes it's very easy to break the feature tree. And so I don't try to avoid it at all times if possible. Okay, and I also like to split up the features from part to part. So I could apply all the fillets at the same time to all the parts, but I just don't like doing that. It's easier to break it up. Okay. We'll add our fillets to this part as well. These are softer fillets. And then the same on our sheet metal part. Okay, now on our sheet steel and our pin, we want to make sure that, let's rename these actually while we have them here. J-cup, barbell, support plate, J-cup, barbell, ultra high, molecular polyethylene, insert. Okay. Now, our plate, our main body, and our pin, we want to make sure that we are assigning these as carbon steel, we'll just say for now. I accidentally refreshed the page there. But yeah, we'll just make sure that That change happened. Carbon steel. And all of our inserts we will assign to, I'm not sure if it's in the Onshape. Yeah, okay, we'll just use HTTP. All right, so now we can actually start building out our assembly. All right, we're ready for the assembly time. Let's do it. We'll come over here, we'll right click, we'll create an assembly. We'll name it J-cup assembly. We'll insert, oh, you know what, let me rename this to J-cup parts. We will insert from our J-cup parts studio. Okay, what we're gonna need, we need our main body, we need our pin, we need 2 of our ultra high molecular weight polyethylene back sheets, we need 1 of our front insert, we need 1 of the supports, and then we need 2 of the barbell support plates. Okay, I'm just gonna move everything kind of out of the way for now. And what I'm going to do is I'm going to build everything so that it's fastened about the origin on the center point of our pin. So first thing I'm going to do is fasten, come up here, fasten mate, the center of our pin to the center of the origin. And what you can do is while you're trying to select mate connectors, oftentimes it'll try and jump around to a bunch of different parts, and you'll try me selecting this one, and then it'll go to the line and jump around. If you want to retain the selection points in the current view, hold Shift. Now if I go around to a bunch of different parts, I can easily prevent it from jumping around. And the same goes for the origin. If I hold Shift, I can now select the cardinal directions a lot easier. Okay. And one thing that I should do as well is create a mate connector in the parts studio that is at the location of the pin where we created it. Because if I just use the center that it's pulling from here, I know that in this case it's actually the center and it would line up fine. But if I start changing stuff around, then it's not going to align with how it's drawn in the part assembly, in the part studio. So what I'll do here is I'll create a mate connector by hitting Control M. I'll hold it on the, assign it to the back face of the pin that we created. And I want the owner entity not to be the pin, but to be the main body part. You'll see why. Now the mate connector appears on the main body exactly where it is on the pin in the part studio. So now we can very confidently mate this to this, and we know that it's always going to line up based on how it is in the part studio. Okay, that's that one. We'll fasten this hole to our part here, and we will fasten the other one to the bottom. Like so. We'll rotate it so it lines up. We will fasten this whole surface, or whole edge, to this whole edge. Now things are coming together here, looking pretty good. Okay, so let's add our fasteners that are going to hold these plastic parts in. And these are going to be short fasteners. Looks like 6mm countersunks. So we'll insert from Onshape's standard content library. We will select hex socket countersunk head screws, M5 by 6. We'll select those 2 edges and insert. Sometimes when inserting countersunk screws, it does some weird stuff. It's inserted them backwards. Oh, I've selected the wrong edges, I think. We'll select those, insert. No. Okay, I'll just insert. And I will make that to here. And those do not look long enough. Oh, it's because I measured from the wrong side. So, okay, yeah, we'll use 8mm screws. So we can come in there and we can update edit the standard content instance. We'll say 8 and update. That's going to update that length so that it's now engaged with the tapped holes. Okay, and instead of like doing that every single time, what I can do now is I can replicate that part. In all areas. Okay, so now we've got our main screws in there. And yeah, we'll do something similar that we did with the pin in terms of adding the main connector in the Part Studio for the for our plastic insert as well. So we'll just hit Control M, attach a main connector there, and we'll say we want that on the main body. So if we pull this back in, now we know that when we fasten in the center to this connector, everything's going to line up. Now if we fasten that hole to there, that hole to there, bada bing, bada boom, we've got our assembly done. Oh, no we don't, we gotta add these fasteners in here. So those fastener lengths are gonna be pretty long. It looks like they're gonna be 40mm. So we'll come back in here. They are button head screws. So socket button head screw. They're M5 by 40mm. We'll select these edges. We'll insert. We'll come around to the back side. And we'll add the nuts. Nuts, hex nut, hex flange nut. Perfect. We'll select those edges. Insert. Alright. There it is. Our finished J-cup assembly. And I will add another video soon going over making the manufacturing drawings for this part. So that's also a really good thing to practice, is making clear, concise manufacturing drawings that effectively convey exactly what you want to be made to anyone with that drawing. So anyone can take that drawing, follow the instructions on it and the dimensions, and churn out exactly what you want. So yeah, thank you for watching. And again, I think this is one of the best ways to learn practical CAD modeling skills for mechanical parts and assemblies. It's just, if you're out and about in public, something cool catches your eye, or even at home, just pick it up, look at it from a bunch of angles, take some reference pictures, and think through how you would go about designing it in CAD. And oftentimes you'll notice little tricks and ways of building out feature trees that will be ingrained in your memory, so that going forward in your work, or next time you're making a part for yourself or an assembly for anyone, you'll instantly have that recall and be able to apply it to the situation you're in right now. I'm also going to make this link available. If you want to come check out this document, you can copy it, see how I built it out, and yeah, just mess around with it yourself. All right, cheers.